And I'm not sure, on page 4 in your pink packet, I don't know if you have enough space. You got a little bit of space. Okay, so I want to talk about what these definitions are because I don't feel like we gave enough information here. So let's talk about what is a maximum. The maximum, I'm going to write it over here. The max is the highest point. Now, this can also be called an absolute max. So just know max and absolute max is the same thing, but it's the highest point on the graph. So the maximum is the highest point on the graph. The minimum is the lowest point on the graph. So let me zoom in. Minimum, which is again could be called an absolute minimum, that's the lowest point. All right, the next thing is called relative. So in this book, it calls it a relative max, a relative min, and pre-calc is called a local max and a local min. You see how everything has two names? So we're going to stick with what the definition is listed in this book. A relative max, I kind of think the easiest way to describe a relative max is every hilltop. Every hilltop is going to be a relative max. Even if it's an absolute max, it's also going to be a relative max. And then the relative min, I always kind of struggle with what's the opposite of a hill. I don't know. So I'm just going to say it's a valley. The relative min, that's every single dip or valley. Okay, so that's my non-mathematical definition of these four things. And I'll give you a moment to copy that down because I think the definition in the book, very, very confusing. Those definitions, unless you speak math, that doesn't make sense. Now, I also want to add, because odd degrees have opposite arrows, every single odd degree doesn't have any absolute maxes or mins. And let's talk about why that is. Remember, the max is the highest point. If I have an arrow going up towards infinity, does it ever hit the top? If you continue to go up, 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 you never hit the top. And if you continue to go down, 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 you never hit the bottom. So that's why odd degree functions don't have, I'm watching phones, I need phones put away. That's why odd degree functions, because they have opposite arrows, they don't have a max or a min. Okay? So now let's look at the example we have at the bottom. And we're just going to write this in. I don't know why it's not there, but we're going to write it in. Max, min, and then I'm going to abbreviate this as REL max, REL min. I'm going to write that for both of them. So we're going to look at this graph and we're going to answer all of these questions. Where are all of these located? So which one of these do you think I'm going to write none for? Max or min? Max. Do you notice how both sides continue to go up forever? If you continue to get better, go higher, go higher, go higher. If you continue to go up, you never hit the top. So this will be a none. We don't have a highest point in this graph. Now we do have a dip. The dip is occurring right here. That point is going to be listed as your minimum and it's your relative minimum. And I'm going to abbreviate that and say that it's 0, -5. So 0, -5, I'm going to put that in two places. And this graph doesn't have a hilltop. A hilltop would look like this. It would be a place where the graph does something like this. So for example, this would be a hilltop. This graph is just a simple quadratic parabola. It doesn't have a hilltop, so it doesn't have a relative max either. That would be none. All right, let's look at this next one. What kind of degree do you think we have here? Odd or even? Who says it's even? Who says it's odd? Are the arrows going opposite direction or are they going in the same direction? Opposite. Remember, odd, opposite. So because this is odd, then we don't have a max or a min, because one side is going up and the other side is going down. Now we do have a hilltop. This point right here, that's called a relative max. It's not the highest point, but it's the point where it goes up and then starts to go down. It's the hill. And that looks like it's about -2, +8. So -2, +8. That would be my relative max. And then I also have a dip right here, or a valley, and that would be a relative min. And that's approximately 0.4. So we're going to look at a few more graphs and then we'll do one of the homework questions. So let's go to the next page. All right, now they gave us all of them so we can actually do it. Do we have a max or min? Which one do you think we don't have for this one? We don't have a max because this is an even degree and both arrows are going up. So because of that, it never hits the top. So for max, I'm going to say none. Now, I really don't like this graph because we have two valleys and they look like they're at the same place, the same Y value. So this and this, they're going to be minimums and relative minimums. I have to list these points twice. So my first point is at -2, -4. I'm going to put that here. And I'm going to put that here. And my second point is at +2, -4. And that goes in both places. Now, if one of these was lower, so for example, if it looked like this, right, where one of the dips was definitely lower, then we would only put, well, we would still put them both for a relative min, but we would only have one actual minimum. But because this one, they both appear to be at the same place, we're going to list both of them for both. All right, and then lastly, the hilltop. We got a hilltop right here in the middle. This would be a relative max. And what would we call that point as an order pair? 0, 4. Any questions? All right, let's look at our next one. What kind of function do we have? Odd or even? It's odd. How do we know it's odd? Opposite. So because it's opposite, I'm going to say none for both of these. Because one side is going up and the other side is going down. It doesn't have a highest point or lowest point. Do you see a hilltop, though, in this graph? Yeah. Right here, this would be my relative max, which looks like that's about 0, 2. Do you see a dip or a valley? Yeah. Right here. That would be my relative min, which is about 1, 1. Any questions? All right, so we're going to start working on the homework. So go ahead, take out your homework. Remember, this assignment is due on Thursday. We're going to go to the back. And we have 4 graphs. Now, tomorrow, we're going to talk about zeros. So we're still going to ignore that for today. So we're not answering 2 of those questions. So let's start off by looking at, I think I want to do the first one because this one has 2 dips and one of them is definitely lower. All right, so let's look at this graph. Remember that this is the same as this. It's just 2 different ways to ask the same question. A maximum and an absolute max is the same question. Yes. Does it not have a maximum? Right. So, but that's asking you the same question. And then the minimum and absolute minimum are the same question. All right. So like Carmelo said, because the arrows are both going up on both sides, we don't have a max or a absolute max. So for both of those, we're going to say none. Now, we do have 2 dips. Would you agree that one of the dips goes lower? It's not at the same place like the one in our notes. So this point right here, that point is going to be listed in 2 places. Because remember, for relative mins, we put every single dip. All right, so this is my absolute min. And I also have to list it as a relative min. I'm going to approximate that to the best of my ability. I'm going to say that that's -3, -1.5. That's the very lowest that the graph goes, so that goes here. But it's also a dip, so it's going to also go here. Every single dip is a relative. All right. We also have another dip right here. Now that one is not an absolute, but it is a relative. Every single dip is a relative. It's not the lowest one, but it's still a place where the graph dips. So it is a relative mean. So I'm going to also list that point here. Oh, I forgot to list that purple point. I forgot to put it here too. Because remember, a minimum is the same thing as an absolute. So we got to put that here too. All right, do we have a hilltop in this graph? Yeah, we do. We have a hilltop right here. That would be my relative max. It's not the highest point, but it is a place where we have like a hill. So I'm going to call that point 0.3. Now tomorrow, we'll talk about these two. We're not going to talk about that today. But let's fill in these two real quick. Let's circle. Do we think this is an even or an odd degree function? Even. And how do we know? Same direction. So I'm going to circle even. Do we think it's a positive lead or a negative lead? Positive. All right. They're both going up. Now remember, the right arrow tells you if it's a positive or a negative lead. But they're both going up, so this is positive. So when I look at this one, do you see how the right arrow is going up? That's how I know this is a positive lead. And this one, the arrow on the right is going down. So what does that mean? What kind of lead would it be? Negative lead. And the last one on the right is going down. So what does that mean? Negative lead. All right, so I want you to use this time, fill in as much as you can on the back.